Okay, we're going to begin this week talking about covalent bonds with chapter 8. Remember, if you haven't started reading the chapter yet, you need to get started with that. Also, if you do not have your notes out in front of you, you need to go get your notebook and a pen and get all of this down, okay? All right, the objectives for this lesson will be first to apply the octet rule to atoms that form covalent bonds. So remember, when you have any element, the most stable it can be is if it has all 8 electrons in its Lewis dot structure. I also want you to describe the formation of single, double, and triple covalent bonds. We will start tomorrow talking about single bonds, and then we'll get into double and triple. Remember also, covalent bonds are where you share electrons, as opposed to the ionic bonds we've been talking about, where one element is giving up electrons and another is taking them on. Okay, I want you to contrast between sigma and pi bonds. So these are all of the objectives for 8.1. Really, for today, we're just going to be talking about this first one with the octet rule. So objective: atoms gain stability when they share electrons and form covalent bonds. So you have a greater stability when you're sharing electrons than when you have an ionic bond. All right, here's your vocabulary. Make sure you get all this down. We'll probably be having another vocabulary test like we did for chapter 7. So your vocabulary words, you pause the video here if you need to. Covalent bond, molecule, should be just a review. Lewis structure, sigma bond, pi bond, endothermic reactions, and exothermic reactions. All right, so why do atoms bond? Atoms gain stability when they share electrons and form covalent bonds. So just remember, they're sharing. Okay, so covalent bonds are when you share electrons. Lower energy states make an atom more stable. So the lower your number in your energy, the more stable the bond's going to be. Gaining or losing electrons makes atoms more stable by forming ions with noble gas configurations. So this goes back to last chapter where we might lose, let's say, a 6s2. We might lose these 2 electrons so that we have a whole 5. We have 5s2, 5p6, 5d10. This would make the noble gas electron configuration where you have everything within that 5. Okay, but you've lost these 6. Sharing valence electrons with other atoms also results in noble gas electron configuration. So sometimes, even within covalent bonds, you could have the same noble gas electron configuration. So atoms in non-ionic compounds share electrons, right? The chemical bond that results from sharing, we already talked about this, is covalent bonds. And a molecule is formed when 2 or more atoms bond. So here, going back, review for vocab from chapters and chapters ago. Diatomic molecules. Okay, diatomic molecules are anything like H2, F2, O2 that exist because 2 atom molecules are more stable than single atoms. So you're never just going to have oxygen sitting out in nature on its own. There's always going to be 2 of them together. Okay, part of this is down here with the forces of repulsion and attraction. Not only are these being attracted to each other so that they can share electrons and be more stable with 2 full octets, but also you have a force of repulsion pushing them away from other things, which even makes them come together with a stronger force. The most stable arrangements of atoms exist at the point of maximum net attraction, where the atoms bond covalently and form a molecule. So here we're taking the example of fluorine. So you have 2 fluorine atoms. If you draw out their Lewis dot structures, you'll see that there's 7. So we have an empty spot here, we have an empty spot here. So what happens is those two come together and we end up having them share. They each are sharing one electron with the other. So we have two electrons here. We call the bonding pair. Those are the ones that they're sharing, making the covalent bond. Okay, that should have been short and sweet for you today. Not a whole lot. Tomorrow in class, we'll finish up the rest of this and talk about single bonds. Okay, thanks a lot.